Well, we have another question here, question 5. We're doing question 5.1. That says if x equal to 3 sine theta and y equal to 3 cos theta, determine the value of x squared plus y squared. All right, I want to write the question here. 5.1, we are looking for x squared plus y squared, given the condition, okay, the values of x and y are given. Now, so it's going to be like x squared plus y squared, okay? So we're having the values of x is like 3 sine theta, and that is 3 cos theta. Now, this will be 9 sine squared theta plus 9 cos squared theta. And now we have 9 common. We can take 9 as a common factor because 9 appears over here and there. So we can just take 9 as a common factor. And there we have sine squared theta plus cos squared theta. And there's a property that says that sine squared plus of the angle plus cos squared of the same angle equal to 1. So this will be just 9 times 1, and then this is equal to 9. So the answer is 9. You can say x squared plus y squared. Here will be 9. All right, the following question says, the following question is over here, says simplify to a single term, okay? We have given, let me write, we have given like sine of 540 minus x. I'll do this. 5.2. She's sine of 540 degrees minus x. And then times sine negative x times sine of negative x. And then minus cos of 180 minus x. Oops. Minus cos of 180 degrees minus x. And then times sine of 90 degrees plus x. All right, so we need to have like formulas or trig functions in mind when properties and theorems all in mind when we reduce trigonometric expressions. Like in this case, we have like sine of 540 minus x. What we can see here is that sine 540, okay, maybe let's see, let me draw a circle just to show the rough sketch here. A full revolution here is 360 degrees, okay? A complete circle is 350 degrees. But when we see 540 like this, it means we first did the first circle, 360 degrees, and remember after 360 degrees, for the sine, for instance, 360 degrees a period. Okay, every 360 degrees the values are the same. So this can be first reduced to sine of 180 minus. Okay, I'm going to do this way. And I write 180 here minus x. Why? Because the first round was 360 degrees from here to that 360 degrees, 360, and then to reach 540, we need to add another 180 degrees. Okay, so so this is like the first round is like everything up to 360 is the same, and then we add 180, so just gonna be sine of 180 minus x. Now times sine of negative x. Okay, that's a property. It says that sine of negative theta is it is equal to negative sine theta. So this will be times negative sine theta. Okay, then minus cos of 180 minus x. Now we're going to look. 180 minus x is in this quadrant. Okay, that's 180 minus x, the second quadrant. Now that's 180 minus x is here. Now we ask ourselves the question, like, how is cos in the second quadrant? We know cos is positive only in the first and fourth quadrant. Over here it's negative, so this will become negative cos x. We can reduce it to negative cos x. Okay, and then sine of 90 plus x is that is cos of x, can be reduced to cos of x, so times cos of x there. Now sine 180 minus x, meaning we are in this quadrant, the second quadrant. Okay, 180 minus x is here, and now we know that sine is let me there is here, sine is positive on the first and second quadrant, so this will still be sine x. Okay, so sine x times negative sine x. Okay, and then that makes positive cos x times cos x, and then sine x times sine x makes that makes negative sine squared x, and then plus cos squared x. Now the question says to reduce to a simple trigonometric formula. So this one is the same thing. We can rewrite this way: cos squared x minus sine squared x. And then this reminds us the double angle, because this is equivalent to cos of 2x. Thank you.